Hello, Math 2 students. This video is going to be in two parts. Part 1, we're going to review what A and C mean when you're looking at a quadratic function. And then in Part 2, we'll do an example where we learn some new things about the B value in the quadratic function. So to start with, the graph that's on the screen right now is the graph of y equals x squared. That's the parent function of every quadratic function. The next graph that's going to show up, if you look right here where the cursor is y equals 2x squared. We know that the coefficient in front of the x squared is the a value. So when our a value is 2, we'll have a graph that is a vertical stretch in comparison to the parent function. A vertical stretch makes the parabola narrower than the parent function. If we have an equation like this one, y equals negative 2x squared, we will have the same vertical stretch of 2, but a negative a value will cause a reflection over the x-axis. So our parabola will open down. So now you can see we have a parabola that is narrower than the parent function because of the 2, and we have a graph that's opening down because of the negative a value. The next graph we want to look at is y equals 1/2 x squared. So now our a value is a positive 1/2. Our parabola will open up, but it will be a vertical shrink, which will cause the graph to be wider in comparison to the parent function. The next graph, the a value is negative 1/2. So we know that that's going to have a vertical shrink, which will make it wider than the parent function, but because of the negative sign, it will open down. So we'll have a parabola that opens down that is wider than the parent function. So those are the different things that can happen when you have a different a value. If the a value is greater than 1, you're going to have a vertical stretch. If the a value is a proper fraction, you are going to have a vertical shrink. If the a value is positive, your parabola will open up, and if your a value is negative, your parabola will open down. On the next graph right here, y equals x squared plus 2, our a value was 1, just like the parent function, but now we have a c value of 2, our constant term. It's not connected to an x, it's 2. That will cause a vertical translation of 2. It will look just like the parent function. So here's the parent function. Its vertex is at 0, 0. Now we have a vertex at 0, 2. It was a vertical translation. One important thing about the c value today is that the c value always tells us the y-intercept. So the next one, we have y equals x squared minus 2. So we know that our y-intercept will be at negative 2. So the blue graph is exactly like the parent function, but it's been translated down 2. Now its vertex is at 0, negative 2, and its y-intercept is negative 2. The final graph we want to look at is y equals negative 3x squared minus 4. Here's what we know. We have an a value of negative 3. The negative sign will cause it to open down. The 3 will cause it to be a vertical stretch, and it will look narrower than the parent function. And the 4 will cause the y-intercept to be negative 4. In this problem, it will also cause the vertex to be at 0 and negative 4. So there's our graph right there. So the parent function is in red. This function is in green. Because of the negative sign, it opens down. Because of the 3, it's narrower than the parent function. It has a vertical stretch of 3. And its y-intercept is at negative 4.
In part 2 of this video, we're going to graph the function h of x equals 2x squared plus 4x plus 1. We know this is a quadratic function because it has an x squared. So this is a second degree polynomial. The first thing I'm going to do is rewrite this problem so that it's not in function notation and it has an x and a y. Our equation becomes y equals 2x squared plus 4x plus 1. Now I want to make sure that we identify our a, our b, and our c value for this problem. So our A value in this problem is positive 2. That tells us that we are going to have a vertical stretch and that our parabola is going to open up. So it will look like a U and not like a rainbow. Our C value on this problem is 1. That tells us that our y-intercept is equal to 1. Now, our B value is 4. And this is the first graphing problem where we've had a B value that we needed to deal with. So for the first time, we have A, B, and C. We know that A is telling us there will be a vertical stretch and our parabola will open up. Our C is telling us that we have a y-intercept of 1. Today, we're going to find out how the B can help us make a graph. We are going to find the vertex of the function. And in order to find the x-coordinate of the vertex, we're going to use a formula that we haven't seen before. So the formula for the x-coordinate of the vertex is x equals negative b over 2a. That's how we're going to find the x-coordinate of the vertex. To find the y-coordinate of the vertex, we're going to take our x value and we're going to put it into our original equation. So our y value will be equal to whatever a is, x squared plus bx plus c. That's the general rule for finding the vertex of a quadratic function. So on our problem, we have x equals negative empty bracket over 2 empty bracket. And our b value, as we can see from before, is 4. And our a value, as we can see from before, is 2. So that makes our fraction negative 4 over 4, which is negative 1. When we look at our vertex is going to have an x-coordinate of negative 1. Now we need to find the y-coordinate. So our y-coordinate is we're going to put in our a value, our b value, our c value, and our x value, and we're going to calculate what the y-coordinate is going to be. That will look like this. Y equals, and our a value is 2, empty bracket squared, plus our b value, which is 4 times empty bracket, plus our c value, which is 1. Now, in the empty brackets, there's an unknown. It's a variable. It's x. We used to not know what x was, but now we know that x is negative 1. So we replace the x in the equation with a negative 1. We need to do negative 1 to the second power is positive 1, times 2 is 2, plus 4 times negative 1 is negative 4, plus 1. So now we have y equals negative 4 and 2 and 1. And when we put those numbers together, that comes out to negative 1. So the y value of our vertex is negative 1. So when we go to make our graph, the first point that we're going to put on the graph is at negative 1, comma, negative 1. That would be this point right here, and that is the vertex. The next thing that we want to put on our graph is our y-intercept. And we already know that our y-intercept is 1. So as an x and y coordinate, that would be over 0 and up 1. So when we put that on our graph, that would be this point right here. The axis of symmetry is a vertical line that passes through the vertex that divides the parabola into a mirror image of itself. That would be our axis of symmetry on this problem. Whenever you write the axis of symmetry, you always write it as an equation. And because it's a vertical line, that equation will always start out with x equals. In this case, since we cross the x-axis at -1, our axis of symmetry is x equals -1. Now, the axis of symmetry helps us make the graph because we know that that point at the y-intercept, that point at 0, 1, is going to have a partner that is its symmetrical point on the other side of the axis of symmetry. That point is going to be here. So if there's a point at 0, 1 on our parabola, because a parabola is symmetrical, because the left side and right side are mirror images of each other, then we're going to have a point at -2, 1. So notice that both points are the same distance from the axis of symmetry. They're both 2 spaces away from the axis of symmetry. So now when we draw our parabola will look like this. It goes a U-shaped curve that passes through those 3 points. My third symmetrical point was -2, 1, and that was the third point that allowed us to actually graph the parabola. Now, we're going to find the domain and the range. The domain of every quadratic function is all real numbers. So right away, I can write that down. And what that means is that any number that you can possibly think of will be one of the x coordinates of some point that is on our parabola. The next thing we need to do is find the range. Now, the range is not all real numbers. Our vertex is at -1, -1, and obviously our parabola doesn't reach down below -1 on the y-axis. If we try to make a list of all the y coordinates of every point that could be on our parabola, there's never going to be a point with a y coordinate that is less than -1. Our range on this problem is y is greater than or equal to -1. Finally, what is the minimum or maximum? Well, we know if our a value is positive, our parabola opens up. The 2 arrows at the top of the parabola tell us that this parabola is going to go up forever. So there is no maximum value. Any parabola that opens up has a range restriction, which means it will not go below a certain number. And on this problem, it's the y coordinate of the vertex. It will not go below -1. So although our parabola will go up forever, it will not go below -1. On this problem, our minimum is going to be -1. All right, to summarize, we found the vertex, and to find the x coordinate of the vertex, you use the formula x equals -b over 2a. To find the y coordinate of the vertex, you use and you replace the a and the b and the c with the a, b, and c value from your function, and you replace the x's with the x value that you found out by using the equation x equals -b over 2a. So you need to find the x first so that you can put it into the function in the place of the x. What does the x coordinate tell us? Besides telling us how to get to the vertex, the x coordinate also tells us what the axis of symmetry is. And that's the line that divides the parabola into a mirror image of itself. It always passes through the vertex, and it always has an equation that is x equals whatever the x coordinate of the vertex is. Now, what does the y coordinate tell us about the graph? Well, the y coordinate tells us how to get to the vertex. That's one of the things that it does. The y coordinate also tells us the maximum or minimum of the function. Remember, if the parabola opens up, it will always have a lowest point or a minimum. If the parabola opens down and looks like a rainbow, it will always have a maximum point at the top. And that maximum or minimum will always be the y-coordinate of the vertex. The other thing is when you're calculating the domain and the range, the y-coordinate tells you the range restriction. By looking at the y-coordinate of the vertex, you will be able to tell where the range is restricted. The range will not be all real numbers, and by looking at the y-coordinate, you can tell which points on the graph will be a part of the range and which points on the graph will not be a part of the range.